All right, then 7.1 inverse variation and direct variation. So first of all, chapter 7 is concerned about rational functions. And in this rational functions chapter, we have 5 sections. 5 sections for chapter 7. Okay. I know there's, even those 5 sections, it's going to take more than 5 meetings to cover this stuff. Hey, that's showbiz. So first thing, inverse variation. Inverse variation is when you have 2 items. Here's 2 items. When there's a formula when they're related as follows: when x times y equals some k constant, some constant. Okay, these will vary inversely. So here's a constant. In this case, I'm picking 12. The number 12 is a constant. When x is 3 times, the only number times 3 to give you 12 would be 4. So 3 times 4 would be 12. What happens if we take this number and decrease it down to 2? So the constant, when you multiply these 2 numbers, it still has to remain that constant, whatever that is. In this case, it's 12. 2 times what is 12? It's 6. What happens if we take that and decrease that? Bring it down to 1. 1 times what gives you 12? 12. So when these things are inverse variation, when this goes down, this value increases. When this value decreases, that value increases. So when you multiply them, 1 increases, 1 decreases. What if you took this value and said, I'm going to increase that? What happens to the other value? When this value increases to 4, this value will have to decrease. So when one increases, the other has to decrease. It's inverse variation. Okay, they're inversely related. When one goes up, the other goes down. That's inverse variation. Okay, it's not the same. It's just inverse variation. Sting like a bee. Boom. Okay, direct variation is different. You'd set it up like this. In this case, I'm going to pick the constant k to be 4. And 12 divided by 3 is 4. What happens if we take 12? I'll take this 3. I'll take 3 and increase that to 4. What times 4 gives us 4? 16. Hey, when this increases to 4, this also increases. So they're both increasing. It's direct variation. When one goes up, the other goes up. What happens if I take that and increase it to 5? 3, 4, 5. From 4 to 5, what happens to this? In order to keep that constant to be a 4, this has to be 20. So when this number increases, that number also increases. It's direct variation. Direct variation, they're both increasing. Oh, what happens if we decrease it? Let's say 5, 4, 3. Let's say the bottom number is 2. What if we take that and decrease it to 2? If this value is still going to be 4, that's the only number that can go there. If this decreases to 2, what happens to this number? That also decreases. So when one goes down, the other goes down. Or if one goes up, the other goes up. That's direct variation. Okay, that's the difference between direct variation and inverse variation. Okay, inverse variation is set up this way. Direct variation is set up this way. Okay, now let's see what happens when you put this into practice and look at some of these problems. So this cell's down here. Get a little closer. Tell whether x and y show direct variation, inverse variation, or neither. Okay, right there, neither. Can't even see my finger right there. There we go, that's a little better. Okay, y. So this is not set up. I'd rather have it set up like this. So number 3, it's set up like this. I want the letters to be on the same side. So I'm going to take that x and get it on the other side. So we have to multiply both sides by x. So now it looks like that. So when these letters are next to each other like that, that is set up like which one? Which one is it like? Boom, inverse variation. This is inverse variation. If x increases in value, y would have to decrease in order to stay as a value of 2. What about number 11? Number 11, right here, number 11. Tell whether x and y show direct variation, inverse variation, or neither. Okay. So x is increasing, 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 increasing. Y is increasing, increasing. They're both increasing. So I know, since they're both increasing in value as I go this way, I know it's not inverse variation. Can't be that. So it's either neither or direct. Now, if this is the case, the constant in this case, I could take 12 divided by 132 or 132 divided by 12. 12 divided by 132. I'm going to get some fraction. Those numbers are harder to memorize. I'm going to take the bigger number on top. 132 divided by 12. It's 11. So this constant is 11. If they're all going to be 11, this is going to be direct. Hey, doggy doos. Okay. 198 divided by 18. Is that 11? Nice. How about burp? Ooh, 253 divided by 23. Is that 11? Yes. Sweet. 319 divided by 29. It's 11. Beautiful. If any one of these is not going to be 11, then it won't work. Divided by 34. It's 11. So they're all 11. Beautiful. So question number 11. It's direct variation for question number 11. Okay. Let's go to question 13. Straight down to 13. 13, 4, 6, it's increasing. So that's increasing, increasing, increasing. This one's 4 to 5, decreasing, decreasing, decreasing. Okay, so I know it's not direct. It's either inverse variation or neither. So I'm going to take the bigger number divided. I could take 4 divided by 21. So this would be, it's 13. X times y. This would be inverse. So 4 times 21 is 84. 6 times 14 is 84. 8 times 10.5, that's also 84. 8.4 times 10, that's 84. 12 times 7, that's 84. That's inverse variation. Whoops. Inverse variation. Ba-ba-ba-boom. There we go. Number 17. Question number 17. Boom. Question number 17. Let's go right here. 17. Boom, boom. Question number 17 right there. The variables x and y vary inversely. Ooh, key by right here is varies inversely. So I know it's going to do, it's not that one. X and y, and it's going to be some constant. So x, y, so write the values relating x and y, then find y when x is 3. So I'm going to set out this way. xy equals xy. Okay. When x is -3, y is 8. Okay. Find y when x is when x is +3. What does y have to be? So that's how you set it up, and you have to solve for y. So that's a -24. Some people could do this in their head already. 3 times what? 3 times what is going to be 24. This is the way you do it algebraically. Y equals -8. There's no units here, it's just numbers. So it's just -8. So for question 19, you'd say when x is 3/4, so it's xy equals xy. When x is 3/4, y is 28. And when x is 3, according to that right there, when x is 3, it says that right there. Find the value of y. So 4 goes on that once, 4 goes on that 7, that's 21. So right now it looks like this. Divide both sides by 3. And y equals 7. Bada bing, bing, boom. Let's go to the other side. Oh, here we go. Question 25. Right here in question 25. 25. Modeling mathematics. The number of Y songs that can be stored on an MP3 player. Man, that's old. I don't even know if you guys know what that is. You know what a CD player is, I hope. But an MP3 player. It's an old device for listening to music. Stored on an MP3 player varies inversely. Oh, varies inversely. So varies inversely because we got that from this right here. Okay. Varies inversely with the average size of x of a song. The number of songs varies inversely with the average size of a song. Okay. A certain MP3 player can store 2,500 songs. 2,500 songs. When the average size of the song is 4 megabytes. 4 megabytes. So number of songs is 2,500. And we have to make a table. So 2,500 songs, average size of the song is 4 megabytes. Make a table showing the number of songs that can fit in an MP3 player when the average size of the song is 2 megabytes. Okay, so there you go. Here's your equation. When it's 2 megabytes, what's y going to be? When it's the average song is 2 megabytes, what's the number of songs going to be? Divide both sides by 2. Y equals 42 to 5,000. Next, 2, we have 2.5, 3, and 5. Okay, so do this again. So this times this is 10,000. 4 times 2,500 is 10,000. And when it's going to 2.5, 2.5 times y. Here we go. Divide both sides by 2.5. And you get 4,000. That would be 4,000. When it's 3, 4 times, we're just constantly setting it up this way. When it's 3 times y, find out the value of y. When it's 5, so we're going to do it again. I'm going to let you do the calculations. But when the number of average size of a song is 5 megabytes, y is the number of songs, solve for y. That's how you do number 25. So I did these 3 for you. You have to do the last 2. There you go. That's it. Pretty straightforward. Hasta la bye-byes.